Hello, just checking audio 123, 123. Can anyone in the chat please reply if you can hear us? Testing, testing, can you hear us?
Yeah.
Awesome. All right, awesome. And I think this is still sharing. Okay, cool. I think it's ready for it.
Yeah. You want to introduce like that version that they make in the country?
Okay, we're going to get started now, everybody. This is the Foundations of Computer workshop run by CISA. I'll just do a quick acknowledgement of country. Before we begin, I'd like to recognize the traditional land on which we are having this workshop and pay our respects to the Wurundjeri people of the Kulin Nation. This will be presented by Clement, and just a little warning, this is not officially recognized by the university, and they want us to say that, so.
All right, hi everyone. It's a lot of turn-ups today, already a lot more than last semester, so I'm really glad that that's what it is. My name is Clement. Just a bit of introduction. I'm currently tutoring FOC. I've been doing it for the past 2 semesters, so this is my second time tutoring FOC. I'm also currently a student myself. I'm doing Bachelor of Science. I'm going to graduate with my bachelor's this semester in computer science. So if you have any questions about anything outside of FOC, just like Bachelor of Science in general, you can ask me as well. But anyway, we're gonna talk about FOC prep exam advice today. I'll start by reviewing. I'll start by saying that this is not an exhaustive guide. So what I'll be doing actually is I'll be reviewing the content from the MST up until week 12, because the content between week 1 up until the MST is just like, data structures. You learn about lists, tuples, dictionaries, and you've used them in the MST, you've used them in the projects. So I don't think that's very helpful if I cover that as well, and I don't think that's very time-wise not good. So yeah. Also, like even when we covered the slides for week 6 until 12, not every content is here, okay? So this is just a guide. This is meant to be a guide. There's a lot of my slides there, especially for revision, but the main content should come from the lecture still and the ad worksheets, okay? Right. So, like I said, we're gonna do a brief crash course of the 6 weeks, the last six weeks, what to expect in the exam. So I'll go through the exam format if your tutor or lecturer hasn't done it to you yet. I'll give you some tips and advice for preparation, and then I'll try and solve some practice questions in groups or whatever. Right, so this is what we would be covering. So week 5, you guys learned about libraries. Let me see if I can get never mind, there's no laser here. Okay, laser pointer, there you go. So week 5, you guys learned about libraries, lambda, map filter, types of errors. Week 6, again, you learn about commenting and docstrings. I'm not going to cover commenting and docstrings. When writing code in the exam, you are not needed or required to write commenting or docstrings. So please don't make that mistake in the exam because the exam has time constraint. And then you learn about these comprehensions, files in week 9, recursion in week 10, week 11 ethics, and then week 12 is just revision. I'm not sure why it's missing week 8 here, but anyway. Okay, so libraries as a revision is just a collection of code that someone wrote out there, and then if you use the import statement right here, you're able to get all those functions and then use it yourself. Okay, the common ones we use in the subject, of course, it's math. Math gives you functions like square root, log 10, and factorial. It also gives you constants like pi and e. So pi and e are kind of like infinite numbers. it's really good to use libraries because obviously you don't want to be like hard coding it. So that's one thing that libraries give you. It also gives you constants instead of just functions. And then one of the more important ones is collections, because collections gives you the function for default dict, which a lot of you guys use in the projects as well as the MST and in the exam as well. Okay. Feel free to stop me anytime, but I'll just go rapid fire through all the slides because there's a lot of them. Yeah, default dict. Without default dict, this is like a 5-line type of library. Sorry, 5-line to make like a regular dictionary. If I'm going to count all of the characters in my string, this is the 5 lines that goes on when making a dictionary. But with default dictionary, I can specify the type of the value, and then whenever I initialize, it will automatically initialize to the 0 value of that type. So if this is int, whenever I initialize a new character, it will initialize to 0 first before it adds 1 to it. This could be lists, could be strings. If it's a list, it's an empty list. If it's a string, str, it's an empty string, and etc. Okay. Lambda functions. So lambda functions are, as a reminder, 1 line to making functions. So if I have this one function here that returns the last character, I can use lambda to essentially do the same thing, right? But you don't want to be defining functions like this. Usually we use lambda to pair it up with functions like sorted or map or filter. Yeah, there's no filter here for some reason. Anyway, so for example, I want to sort animals by the last character. I can do sorted animals key last character, or sorted animals key lambda as colon as -1, which indicates the last character. Okay. Maps, it's like the map function in maths, right? For example, if I have a list of numbers 1, 2, 3, 4, 5, and then I want to fill in this squared list with all the squared numbers of that list, of the original nums list. This is how I would do it without map. I have to loop through every number and then append the power of 2 of each number in the list. But for map, I can do it in 1 line. So map, the left-hand side argument is always the function. So here I'm using lambda again to make it a 1 line. Lambda num colon num multiplied by 2. And then I'm giving it an iterable. Can be a list, can be a string, can be a tuple. This time it's a list. The iterable is nums. Okay. It's important to note that map and filter, I don't have filter slide here for some reason, but map and filter, they give you a map and filter object, okay? So if you do this without the list and then you print it out, it will give you a map object instead of an actual list. So you have to convert it to a list if you want to print it and see the actual list. You can also convert it to a tuple, but the main objective is not to print out a map object. I don't have I have this. Okay. So if you print out without the list, you'll actually get something like map object at blah blah blah, the address, right? So you want to make sure that if you want to print it and see the actual list or the actual content, you do have to wrap it around in a list for map and for filter. Right? Just a reminder. Okay, any questions so far? All good? Right, feel free to stop me anytime again. I'm just going to rapid fire these slides. Types of errors is very important. There will be one section that will focus on types of errors, as I will discuss later in the second half when we go through the exam questions. So syntax errors are if statements, like for example, if you have an if statement without a colon at the end, that's a syntax error. Essentially the thing won't compile, but it will tell you what the error is. And if you have like unmatched brackets, an opening bracket without a closing bracket, it'll also be a syntax error. Runtime errors is a different type of error. It's not violating the Python language, but you're violating like the general programming language, if that makes sense. So index error, when index goes out of range, that's a that's a runtime error. Type error, if you're adding a string with an int, right? You're adding 5 with like a hello, for example. That's a type error. Key error for dictionaries. You have zero division error for when you're dividing it by 0. And then you have name error, which name error is when you don't have a variable You're trying to reference a variable that doesn't exist, that you haven't defined. That's a name error. Attribute error if you're using, for example, string.upper, but the first U is capitalized, that doesn't exist, right? So that's an attribute error, which means that the attribute doesn't exist. I think attribute, no, it doesn't matter. Anyway, yeah. Logic errors, simply is when your program is not getting the expected output. Your program will compile, your program will run, but it's not getting the expected output. So if in your projects you're failing hidden test cases, that's the easiest example of a logic error, right? You're failing test cases, your code is not outputting what is expected by the requirement. And so this is the hardest to debug because the compiler shows no error feedback, okay? So 3 types of errors, very important. All right, I'll move on. You also learned about list comprehension. So list comprehensions, again, it's a one-liner. It's a one-line way to make lists. And if you see like this kind of like chart here, or like this example here, where essentially if you do it normally, like every element has its own place in the list comprehension compared to doing it when you do it like normally. I've seen a lot of projects with list comprehension, so I'm going to assume that you guys are good at this already. List comprehensions, there's a lot of types. Obviously, you have the regular one. You also have a regular list comprehension with an if condition. So I for I in range 10, if I modulo 2 is equal to 0, it will only include numbers that are even. You also have list comprehensions with an if-else condition. So I could say like if I modulo 2 is equal to 0, else I will just I squared it for I in range 10, okay? I can also do a nested comprehension. So what does a nested comprehension mean is if I have 2 for loops, then this would be a nested for loop, like in the regular code. Okay, so here I have for I in range 10, for j in range 10, I'm including ij, so you can expect this to have like 100 elements in the list of like just a combination between I in range 10 and j in range 10. Okay, cool. You can also do dictionary comprehension. So a dictionary comprehension works the exact same way, but you have this presence of a colon here. So I colon I squared for I in range 10. So what this will output is, you can kind of guess 0 colon 0, 1 colon 1, 2 colon 4, 3 colon 9 is just 4 squared 16, 5 squared 25, and etc. You can also do set comprehension. This is the exact same as the example last slide. So I for I in range 10, if I modulo 2 is equal to 0. But instead of a square bracket, I'm doing a curly bracket. Sets, right? And then if you use tuples, or if you use like rounded brackets, it's not gonna give you a tuple comprehension, it's gonna give you a generator, which I don't know what it is, and thus it's not examinable, okay? That's all you need to know about comprehensions. Cool, no questions. And then you talk about iterators. Iterators, I like to say that it's a concept rather than like a topic. But simply with iterators, you have an iterator. So an iterator can be a list, can be a tuple, can be a string, can be files. Files is a good iterator. I think that's one of the most important examples. And then if you build an iterator object with the iter keyword, and then you keep doing next, they keep printing like the next one in the list, okay? And if you print next again, if it's already at the end of the list, it will raise a stop iteration error / exception, okay? How do we avoid this? We can use cycle to avoid that. So cycle is imported from itertools. It's from the itertools library. And then if I'm cycling through this list, ABC, that's an iterable, right? 4 times, I will print A, B, C, and then back to A the next time, okay? You also learn about product. So product is essentially a permutation, but not necessarily with 2 elements. You can do it with 3. Here, I'm doing it with 3 elements. So if I have Apple products, for example, I have laptop, phone, and tablet, and then I have these sorts of colors, so yellow, red, pink, blue, and green. And then I have these sizes, 128 gigabytes to 256, 512. and then I'm doing a product over all of them. It gives me all the possible combinations of the Apple product I want to sell, for example. So here I have laptop yellow 128, laptop yellow 256. I can make a laptop yellow 512. I can make a tablet pink and then 256 gigabytes and then etc. Okay, cool. Permutations, it's exactly the same as the one in maths. So if you put in an iterable, can be a list, can be a string, can be a tuple again, and then you put in a number, it will give you all the possible, I'll say like groupings of size 4 of this list right here. Permutations, they care about ordering. So you can see here that here you have A, B, C, D, but then somewhere here, like somewhere on the depths of this list here, you have like B, C, D, A or something. Okay, that's the counterpart to combinations. Combinations is the exact same thing, but combinations, they don't care about the ordering, right? So combinations is the exact same thing. Here I have 7 elements in my list. I'm making a group of 5, and then when I print them out, this should give way less elements because they are not going to output duplicates if the set of the tuple is the same. Okay, so I think those two are clear enough. Any questions up until this point? Okay, I'll go on. You also learned about group by. So group by essentially is grouping, as the name suggests, it's just grouping by whatever you pass in onto with the second argument. Sorry, the second argument. Yeah, second argument. So here I have, again, it's imported from itertools. You have to import group by from itertools. Here I have a function that gets the first letter because I want to group by the first letter. So I have to have a function that gets the first letter, or I can use a lambda. That makes no difference. And I'm making a group by object with this list, and then I'm giving it the first letter function. So get first letter of these tuple. And then I'm just looping through the category and the content of the object that I've made with group by, and then it should print this. If you print the category, which is the first argument or the first output, and the list of contents, you should see that you have A and then AB and AD, B, BA, BC and BD, and D has the DD group. Okay. Good. Any questions? No questions? All right, and then you learn about files. So files, this is how you open a file, quite simply. Files has 3 modes, has the read mode, the write mode, and the append mode. This is a type string, and then the file name is also a type string. Can be .txt, can be .csv, can be .anything really, as long as it's a text file. And then if you do open, and I give it a file name and a mode, it will give you a file pointer object. And normally we abbreviate this by FP, so that's what FP stands for usually. If you see them in like code examples, FP just stands for file pointer. Okay. File modes, read, assume that the file exists, otherwise returns a file not found error if you try reading an empty file. Write mode, if it exists, it erases all its contents even before writing to it. This is a bit finicky. This depends on the operating system that you guys use. But we will go with the interpretation that it will erase its content even before you write to it. Okay. If the file doesn't exist, it will implicitly create a new file first. That is the same with append mode. If the file doesn't exist, it will implicitly create a new file first. If the file exists, writing to it will append to the end of the file. Okay. So write mode, you're getting rid of everything, you're replacing it. Append mode, you're just doing it like at the end. Okay. Oh, sorry. Right. Any questions? All good? You also learned about exceptions a few weeks ago, I think. So exceptions are a really, really nice way of catching errors. What do I mean by catch errors? Is if you have a 0 division error, for example, here, or if you have like any kinds of errors, the compiler will not like turn red if you don't like the compiler turning red, right? You can catch the error. So here I have a divide function. I'll put my code inside a try block, and then whenever it encounters an error, For example, if it encounters a zero division error, instead of the compiler printing a zero division error, I can print this custom error instead. So error division by error if division by zero if it's not allowed, and then return none, and then accept type error if it's a type error. If I'm trying to divide an int by a string, for example, I can make a custom error that says invalid input type, please provide numbers. Okay, so that's the general format. Try except you can have like the finally block as well, which will execute regardless of an exception being raised or not, but that's exceptions. CSV file methods. So this is one of the other libraries that is very useful in this subject. CSV. CSV gives you access to functions like reader and dict reader. I don't have a dict reader in this slide. Anyway, with reader, if you do csv.reader visitors, and you print the list of the data that is the output of doing reader, it will give you the list of lists where each list contains elements in one row. So it will give you everything in here, and then all the rows are separated by new lines, and it's separated by list. Okay. The reason we use CSV as a library is because sometimes you have data here that have commas in them. So in project 2, task 1, I've seen some submissions where some students don't use the CSV library and they do it manually with like commas and everything. Just use the CSV library in the exams, because if you have a test case where instead of numbers you have a string where the string have commas in them, the method without using the CSV library won't work most of the time, unless it's very like advanced. Okay. And then you talk about computational counting, namely binary and octal and hexadecimal. This is again, I think, one of the topics that a lot of people are unfamiliar with. So I'll spend a bit more time here. Essentially, binary, octal, hexadecimal are base 2, base 8, and base 16 number systems. So binary is a base 2 number system, which means that it can only contain 0 and 1s, right? Just 2 types of numbers. There's only 2 possible numbers, can be 0, can be 1. That's a base 2 number system, okay? The form is to the power of x, where x is the position from 0 from the right. So if I'm converting this binary to decimal, 1011, then it's simply 1 times 2 to the power of 3, because this 1 right here is index 3 from the right. And then 0 times 2 to the power of 2, 1 times 2 to the power of 1, and 1 times 2 to the power of 0. If I add them up all together, this will give me 11 in decimal. Okay. Binary, you've heard about it. I think octal, a lot of people haven't heard about it, at least before hearing about it in the first time in the lectures. Octal is similar to the decimal system, but with base 8. Okay. So what do I mean by base 8? Base 8, instead of, I think, I'll just move it like behind me, it's easier. There you go. All right. So binary, right? Binary is base 2, so you have to the power of x, right? Octal is base 8, so you have it in the form of 8 to the power of x, okay? This is probably like the maths part of FOC, the only maths part. So because it's base 8, the numbers you see here are all powers of 8. So if I'm converting a decimal to, okay, for the decimal 74, if I'm breaking down what decimal 74 is, this is simply just 70 plus 4, which is 7 times 10 to the power of 1, plus 4 times 10 to the power of 0, right? Because it's a base 10 number, so it's in the form of 10 to the power of x for decimal. However, if I want to convert it to an octal, because it's a base 8, I have to convert it into 64 plus 8 plus 2, because it's 1 times 8 to the power of 2. This is a power of 8, plus 1 times 8 to the power of 1, plus 2 times 8 to the power of 0. this adds up to 74, this adds up to 74, and then when you have it in the form like this, when you've broken it down into the form like this, then you can just concatenate the numbers in front and gives you the octal form of the decimal. Okay. Cool. Any questions so far? All good? So for the binary, okay, so this is another way of converting from decimal to octal. If you have the number in the binary form, you can convert it to octal way easier, okay? Because octals are a to the power of x, this is actually 2 cubed to the power of x, right? Which means that it's like something like this, okay? Which means that if I have a binary, I can make sure the binary is in multiples of 3. If I try convert the binary in multiples of 3, if it's not in multiples of 3, and then if it's not in multiples of 3, I want to modify it so that it's in a multiple of 3, the length of the binary. So here I have a binary 11111 that's length 8 binary. But then if I want to convert it to an octal, I have to have it in multiples of 3 for my converting method. So I have to add 0 at the front, which makes it a length of 9. So here I have 0, 1, 1, 1, 1, 1, 0, 0, 1. And then I'm dividing the binary into a length of 3, and then evaluate the decimal. So the first 3, 0, 1, 1, has a decimal of 3, if you convert to a decimal. The next 3, 111, has a decimal of 7. And the last binary, 001, has a decimal of 1. And then what you do is you just concatenate those numbers together, and then it forms the octal form of the binary. Okay, cool. Hexadecimal is similar to the decimal and octal system, but with base 16. Okay, so it is in the form of 16 to the power of x. And then you have like a little hexadecimal chart here, because okay, we talked about integers and then binaries. Binaries, because it's to the power of x, you can only have zeros and ones in them. Decimal, it's 10 to the power of x, you can only have 0 until 9, right? So 0 until 9, that's 10 numbers. You can't have more than that. Here, you can only have 0 to 7 as digits for octal. For hexadecimal, because we can't represent like numbers more over 10 without taking up 2 characters space. So numbers starting from 10, we're gonna use characters for that. So 10 in decimal equates to A in hexadecimal, 11 in decimal equates to B in hexadecimal, and so on and so forth. So 15 in decimal equates to F in hexadecimal, and that's the highest character you can go with hexadecimal. Okay, because it's a base 16 number system. You can't have more than 15 possible numbers, hexadecimal. Okay. So this is, I'm doing the same method as I'm doing for octal, dividing it into lengths of 4 this time, because 16x is the same as 2 to the power of 4x, right? So I can divide my binary into lengths of 4 if I have, okay, so if I want to convert the decimal 78 into hexadecimal, I'll probably convert it to binary first anyway, because it's the easiest method. So from 78, if I convert to binary, this will be to the power of 6 plus to the power of 3 plus to the power of 2 plus to the power of 1, which gives me this binary form, 0, 1, 0, 0, 1, 1, 1, 0. Okay, and I'm dividing this into lengths of 4. The first 4 is 0, 1, 0, 0. If I convert that to binary, so if I convert that to decimal, this will give me 4. If I convert that to hexadecimal, it will give me 4 as well. Okay, you can see the subscript here, it indicates the base system. And then if I have 1110 in decimal, this is 14 based on number system. And in hexadecimal, this is E. If you look at 14 here, this equates to E in hexadecimal. So 4 and E, which means that 78 in decimal is just equal to 4E in hexadecimal. But that's how you get hexadecimal from decimal. Okay. Order of conversion, the one I recommend at least. Obviously, you can do it as much or like as as many combinations as you like. But normally, if you want to convert octal hexadecimal and you have binary, you can just do it straight away, right? You have a binary, you can convert into octal into hexadecimal using the lengths of 3 or 4 method that I've shown. Or if you have a decimal and you want to convert it to octal, normally you can do it right away if it's quite a small number. However, if you want to convert to hexadecimal, I would recommend converting it to binary first because it's much easier. And you can just divide it into lengths of 4 after. Okay, cool. Unfortunately, you do have to know how to do it in Python. I feel like this is a bit funky as well because the data types are quite weird here. But essentially, if you want to convert decimal to binary, you can use the bin function, stands for binary. So if you give it 7, binary 7, assumes that's a decimal, and then it will return 0b 111. 0b means it's just a binary based number system. 0b 111 as a string. This is equivalent to string 0b0111. Okay, and then you can convert it back to binary. If you want to convert it back to binary, you can use the int function. So the int function actually has a base optional argument at the end. If you do int as a string 1111, 1011, and then you give it 2 at the end, which means that it's a base number system, it will convert this from a base to number system into a base 10 number system, which is int. So this returns 7, and then this without the string 0b0111 also returns 7. Okay, I said it's a bit weird because here you get a string as the output. Here you can't put in the string. I don't think so. I haven't checked yet. But normally you don't use a string here when you convert it back to binary. So it's the exact same thing as octal and hexadecimal. Octal is the same thing but using OCT function. Hexadecimal is the same thing but using the hex function. Okay. The only difference is for octal you want to pass in base 8 when you convert back to octal, and then hexadecimal you want to pass in 16, base 16 when you convert back to int, or yeah, integer. Okay, cool. Any questions so far? All good. You also learned about recursion. Recursion is probably one of the more advanced topics in this course. The lecturers don't expect you to write recursion functions from the beginning, at least not the harder ones. I could potentially see them asking like something like this, like something as simple as this, but definitely not the ones you see in the tutorial sheets. Okay. You might be asked though to trace the function of a recursion call that appeared in the last semester's exam. You're asked to trace what the recursion function call does or outputs at the end. But as far as building one from the start, or no, you're not expected to do it in the exam. Anyway, recursion is quite simply a function that calls itself, right? So if you have a function here, find max, that calls itself, so this find max function is calling another find max function, that's recursion, right? Here, what I'm doing is I'm finding the max number in a list, but I'm not doing it through the max function. Okay. Normally, if you're not insane, you're just gonna use the max function, right? Here I'm even using the max function, but for recursion purposes, I'm doing this. This is probably like one of the most simple examples to visualize recursion. Okay. So in recursion, you have the base case and the recursive case. I'm not gonna go through the visualizer because it takes too much time. But if you're interested at the end, you can let me know. Base case is there to terminate the infinite loop because you keep calling your own function, and then this creates so many objects, so many functions. At some point you want to stop calling the return function, right? And then this base case does that. Essentially, it returns a value or a line that doesn't involve calling another function, so it stops the backtracing. And then you have the recursive case, of course, which calls the other function. Okay, it's a bit hard to explain without a visualizer, but I'll just stop there. So you have two types of recursive calls. The first type is when you call it once every function, this will produce a stick. If you can see here in the visualizer, this is a stick, a very long stick. So only one recursive element in the list, in the function. And then you can also have two. So if you have two recursive function calls in one function, it will actually give you like a tree if you visualize it using the visualizer. Again, this doesn't really matter that much. This is quite advanced for this course. So there wouldn't be a lot of questions testing on this, maybe like 1 or 2 max, I would say. Okay. So don't worry too much if you don't understand quite deeply about recursion. All right, we're going into week 12, the last week. The last week involves digital ethics. Ethics essentially is, what should I say? It's quite a formality. It's not that serious, that's what I tell my students. But you have to know it for the exam, because this will very likely appear in one of the questions, because one of the sections in the exam is a short answer question. And then that's the kind of section where questions like these come up a lot, okay? So we're using the guideline from ACM, the Association for Computing Machinery, Code of Conduct. Essentially, it lists 7 bullet points where you as programmers have to adhere to when making programs or when using them, okay? You can read this, but essentially you have like contribute to society, avoid harm, be honest and trustworthy, be fair and take action, respect the work required to produce new ideas, blah, 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 respect privacy and honor confidentiality, okay? So you are expected to be able to understand this in and out, be able to yap or like come up about examples of why we want to, for example, respect privacy, or like in which cases companies might not respect privacy. So for example, I'm going to use this respect privacy bullet point. If you go to Kohl's, you go to Woolworths, if you see those security cameras on the checkout counter, you want to consider if those checkout cameras or if those security cameras in the store respect privacy, right? Does it have the customer's consent? Or like, does the customer know that their data is being collected? Those are questions surrounding respecting privacy. That's one example to it. Okay. Right. Cool. You also talk about algorithms. This is quite like the baseline of algorithms. Again, this is more of an advanced topic. I don't think you're gonna be asked to write binary search from the beginning, so don't worry about it. But you do have to know the types of algorithms and examples of them. Okay. So there are 2 criteria to judge algorithms in this course that we care about. The first one is correctness. So correctness is if the output is correct or not, obviously, right? What's the use of an algorithm if the output is completely wrong? And then you have efficiency. So efficiency is measured in 2 things. The first one is time complexity. The second one is space complexity. So time complexity is how much time does it take to run an algorithm? How much time does it take to run a function? Okay. And then space complexity is how much additional variable, data, list, tuple is needed to run one function, okay, or an algorithm. Generally, we care a lot more about time complexity compared to space complexity, because space complexity, or like space in general, as we go into the future, is very, very cheap. Okay, if you compare the cost of buying 1 terabyte of USB today compared to the cost of buying like 1 terabyte of USB like 20 years ago, it's gotten way cheaper today, okay? So space complexity isn't that much of an issue. It's more of time complexity, because if you have an algorithm that's very inefficient and takes so long, you can imagine if you're passing it like 1 trillion lines of data, it will take really, really long to execute, okay? Like at the moment, you're working with data that's like 10 lines, 100 lines, 1,000 lines, 10,000 lines. But in the real world, we want to make sure that our algorithm works really well for data that's very, very large, right? You can imagine like Google, Amazon, those types of data. They have like billions of rows of data. Okay, that's why time complexity is very important. You have 2 types of algorithms. The first type is giving you the exact answer, brute forcing. I have an example of a lock here that gives you an exact answer. Divide and conquer. This is an example of divide and conquer. It gives you the exact answer. It's like binary search, that's divide and conquer. And then you have the approximate class or like family of algorithms. The approximate class family of algorithms is when when a problem is really, really hard or takes a long time to find the exact answer. One of the examples here is finding or like predicting the weather tomorrow, right? You can't predict the weather tomorrow like 100%, but if you have like a 95% estimate or like a 99% chance of getting it correct, that's usually good enough, because if you want to have like a 100% success rate, it's usually either impossible or like takes a very long time. Okay. So approximate, the first one is simulation. Simulation, the most popular example, at least in this course, is the weather or like predicting weather example I had earlier. The other very popular example is simulating playing in a casino or like playing in the casino. So you can simulate playing like blackjack or like roulette. If you simulate that over like 1,000 times, what's the average loss per like game that you play, right? Because if you go to the casino, you can expect that the house usually wins in the long run. So you can use algorithms like simulation to kind of like simulate the number of plays and then kind of like get a good average of if you would win or if you would lose in that particular game. Okay. Heuristic search is when we use a function, a very smart function that calculates or decides the answer, the approximate answer to a problem. Here I have an example of a Google Maps search. When you search on Google Maps, when a distance is very far, normally there are millions and millions of routes that you can go through, right? This is not a very good example because this is very short, but you can think of it as like a very complex maze where there's like millions of routes you can go through. And then if you go through like every single route, it just takes a very long time and it's not worth it. Okay. So normally an approximate answer is good enough. And then if you want an approximate answer, you can use heuristic search, where you're going to apply a decently smart function to your input. And then it will give you like an approximate answer of what's a good enough answer to this problem. Okay. That's heuristic search. Okay. So last semester, you're asked to come up with an example for simulation, but do expect them or like try and prepare one or two examples for both simulation and heuristic search. Yeah. Yeah. So simulation is essentially you are running a simulation, right? You can think of it as like if I use the weather example. You're running a simulation with, let's say, like all possible combinations or permutations of like initial data. So the weather one is a bit hard, so I'll go back to the casino part. So if you do a lot of test runs with a lot of inputs, a lot of sensible inputs. So for example, for this weather one, maybe you could run a lot of test runs with a lot of like initial inputs, varying a lot of like different variety of initial inputs, millions of them, and then the output, you probably want to stick with the output that has the highest percentage chance of outputting. So normally with simulation, you have millions upon millions of data of your own like data, which you can like permutate or you can like use combination, and then the output will be like millions as well. But then the output, sometimes usually it will converge to like one output that's very likely. So in the case of weather, you can put in a lot of like initial arguments. I'm not going to go deep into that because it's more like geographical stuff. But if you have a function, let's say you have a function that predicts the weather, and then this function has like 10 arguments, for example, in this weather, or like 20 arguments. You want to play around with those arguments a lot. Like for example, for each argument, you have like 10 different inputs or like 100 different inputs. And then for each argument, for each possible input, you want to execute the function that way. That's simulation. So for example, if you have like 10 million rows, or like 10 million function calls of simulation with different arguments or different types of input, then the output will have 10 million rows as well, but then the output, you want to see like which output is the most likely, or like which output has the most, how do you say, is the most likely, or like which output outputs the most. Yeah. Heuristic search is more of, you're not doing it, you're not brute forcing it, or like you're not doing it multiple times. Heuristic search is more of, you have a really good function that approximates really well. So heuristic search, normally you only run it like one time or like a few times, definitely not a million times like simulation. Simulation, usually you would run it like a million times, 10 million times, 100 million times. Heuristic search, you have this one really good function that's made by scientists, for example, or like made by someone in the research paper, and then you just run that for a good approximation. Okay, so that's the main difference. Sorry if that's not too clear, but yeah. Definitely find more examples on Google, simulation heuristic search, but that's a good question to think about. Okay, any other questions? That's a good question. All good. And then you talk about linear search and binary search. This is again one of the most basic examples of, I'll say, algorithms. Linear search, as naive as that sounds, this is how you do it. If you have a list, for example, like 1, 2, 3, 4, 5, linear search is just going from the left to the right. So if you want to find, is there 6 in the list? You're going to go, okay, 1, is that 6? No, that's not 6. Is this element 6? That's not 6. Is this element 6? That's not 6, and so on and so forth. Okay, so it does not require the elements to be sorted initially, because it goes through all elements in the list iteratively. This is what we can consider a brute force approach, and the worst case scenario is a time complexity of O of n. So time complexity, this O thing is what's the worst case scenario of doing linear search. Okay, the worst case scenario of doing linear search is if the element is not on the list, or if the element is at the end of the list, right? Either one, you have to go through all n elements to find or to search for the element in the list. Okay, so that's why it's O of n. Binary search requires the elements to be first. We should like plug in PC. Yeah, sorry. So binary search requires the element to be sorted first, because if you have, for example, like 1, 2, 3, 4, 5, 6, and you want to perform binary search, let's say I want to find 1, right? I'm finding 1. What binary search does is a divide and conquer approach, where you're going to divide the list at the middle, and then you're going to see in the middle, okay, which one or which element is in the middle of this list, right? You're going to see, oh, this is the element in the middle is 4. I'm going to compare, is 4 equal to 1? So 4 is not equal to 1, but 4 is greater than 1, or 1 is less than 4. So after I compare this, because 4 is greater than 1, and I know this list is sorted, I can immediately cross out this side of the list and only continue searching on this side of the list. Okay, so I'm going to continue doing that. I'm going to check the middle one. So the middle one is 2. Is 2 equal to 1? 2 is not equal to 1. So I can immediately again cross out 2 and cross out 3, because this is a sorted list. And then now I have a list of one element, and I'm checking 1. Is 1 equal to 1? Yes, 1 is equal to 1. So I found my element using binary search. Because it's sorted, and because we keep dividing it into 2 equal lengths every iteration, the time complexity is O of log n. And then log in computer science is log of 2. Okay, so this is actually log of 2n. In computer science, log by default is log of 2 if it's not specified. Okay, and this is what we consider a divide and conquer approach. Any questions? All good? Cool. And then you also cover HTML. I think the lecturer has mentioned that this is quite limited, as in not everything is examinable. But it is still important, I think, for like, just in case, to know what HTML is. To know like HTML is essentially something you use for a web page is a markdown or like a markup language. And then you have like these tags that you can use to make your text like bold or italic. And then you have like HTML entities, special characters, such as those ones. But I don't think it's covered. I'm actually not sure. If it's covered in the exam, I think this will come up again in the question, like explaining what HTML is and stuff. Okay, so don't worry too much about that. Cool. Any questions so far in the revision part of this workshop? Cool. We're gonna go through the common types of questions. Let's see what I have here. Okay. So the exam this semester, like last semester, will be digital format. So the pictures I have here are actually from the, I'll say like from the written format. So last year we actually did a written format, but this year we just switched to digital format. I think what I'll do, how much time do we have left? 11:01, okay. So I have some practice questions for section A and section B. Section A being evaluating the expressions like you did in the MSD. Section B, the one-liners. And then I'll speed through the section C and etc. without practice questions. So for section A, this is what you've done in the MSD. You guys are familiar with it. Give a single expression, us to give the output, or if it's an error. You should know basic Python operations. There's a whole list here. Essentially, you have to know operators, the difference between them, slicing and indexing, these common functions, there's comprehensions, and etc. Okay. You also have to know the logic operator precedence. You have to know that brackets always come first, and then comes exponentiation, and then comes negative and positive arguments like the one at the front. I don't think you guys use this anyway, so it's fine. And then comes multiplication, division, blah, blah, blah. And then comes addition, and then comes the operator. So the less than, greater than, and not equal to. And then comes the not, and or, finally. Okay? Right. Yeah, just take 3 minutes to kind of like see what these output. I've modified these first two questions so it's more tricky. And then I think the rest is pretty straightforward. But and or, keep in mind that and takes precedence over or. So when evaluating this, you want to evaluate and first and before evaluating or. Okay. So take 3 minutes, just read the questions. I would try and do the first two, so 6, 7, and then do the false and false or true. Yeah, just do like the first column. The first column is more like non-trivial. Okay, yeah, take 3 minutes and then I'll discuss after. I'll discuss in, let's see, 11:06. So 1 more minute, or after. Feel free to. All right. So, first one. Oops. Okay. Yeah, that's fine. First one is false. Because uppercase. It's important to note that the first one is uppercase S, the second one is lowercase s, and if you look up the ASCII table, uppercase letters actually has lower ASCII value than lowercase letters. So if you look at the ASCII table, the uppercase letters comes first, and then the lowercase letters. That's why 6 greater than 7 is false. Okay. Even though this is an uppercase, that's a lowercase, but it's actually inverted in the ASCII table. Okay. 6 greater than 7 with the first character being the exact same and the second character being I and E, because I is greater than E. That's why it's true. Okay, the character I is alphabetically after the character E. This false and false, again, N takes precedence. So false and false is false, and then false or true is true. So that's true. 5 integer division 3 is just 1, right? 5 divided by 3 is 1.666, or that's another 67. And then if you do something like this, pi watch 3.14, you can't assign a string to anything. That's the string, that's not a variable, okay? Another thing I want to touch on is you can't name variables. Like, well, this doesn't happen, not that I've seen in MST, but like just as a reminder, variable names cannot start with numbers. So you cannot have like 3 watch is equal to 3.14, right? This doesn't work, okay? I haven't seen it in the MST when I'm marking it, but just as a reminder, you can't have variable names that start with, yeah? This one? Yeah, doesn't matter because because like it's if you divide it in maths, like it's infinite, right? It's the same in Python. If it appears in, I don't think it'll appear in the section A because it will be automatic. It'll be like auto marking, so like it's impossible to accept everything. Maybe if there's like a little program they can, but if it comes up in section A, yeah, just up to you. Yeah, that's fine. Yeah, but just to make sure, I'll send in the ad discussion, just to make sure, and I'll see if I can get like one of the headers to answer it. Okay, so that's a good question. Post it in the forum. Any other question? Right, all good. Okay. Right, and then the other practice question that we're doing is a one-liner. Oh, I just licked it. Okay. Suppose that I'll just do this one. Suppose this list is non-empty. Give a pattern assignment statement that assigns true to and same if the first and last item in list are the same. Assigns false if not. Okay. So first and last item in LST. First item is index 0. Last item is index -1. Right. So you've practiced this a lot in the MST. So just do something like that. Okay. You can do -1 or you can do length of LST -1. That gives you the last element as well in the list. Okay, cool. How to prepare for section A and section B? Remember Python operators. Remember list comprehensions. Section B. Okay, this is an important caveat. Section B in the exam, you're gonna be expected to use lambda functions. Okay, in the MST, you guys didn't use lambda functions because we haven't covered it yet when you guys did the MST. But in the exam, you're gonna expect questions that you have to use lambda functions, otherwise it's impossible to do it in one line. Okay, so expect lambda, expect map, expect filter, expect sorted, and etc. Right? No, because we don't teach it in the network sheet. No, yeah, but. Okay, that's a good point. You can use functions that we haven't taught you. That works. Okay, so you can also use reduce if you want, but we're not gonna have questions that only rely on this one thing. Okay, yeah, that's a good question. So you're gonna expect to have that. maybe some functions in later tools, like permutations and everything, and not Darwin. Maybe not. But anyway, it's still good to learn those for like later sections. Okay. So consider data types and available methods. Pay attention to the variable names. Full marks only if one assignment. Okay. So if we ask you to write a one line, don't give us 2 lines. in the MSc, some students write 2 lines, and then in the marking meeting, people are like, should we give them marks? We eventually didn't give them any marks. Okay, so don't give us 2 lines if we ask you to write a one-liner. Okay, it's a one line for a reason. Yeah. Okay, it's better to write a one line that's partially correct than to write a 2 line that's fully correct. Okay, because if you write any more than 1 line, it's gonna be wrong. Okay, 0 marks. Okay, cool.
Yeah, another question. Like, if you especially talk about to import something.
No, you can't import anything in a 1 line. Yeah, yeah, 1-liner. Yeah.
It's syntaxically perfect. Like, you can in line.
Okay. Yeah, I know. Because you can also write an if statement in 1 line, but we don't expect like that. It makes sense, yeah. Yeah, I know what you mean, because you can also write if statements in 1 line. Okay, that's a good question. That's another good question. Okay. Any other questions? All good. Yeah, that's a meme. If you're wondering, Python just had a birthday a few weeks ago, 3.14. Python. Okay. Anyway, do I want to do this? Let's see, how are we doing for time? Yeah, I think we can do this. So I'll give you 3 minutes, 4 minutes. Just try and do that as a practice. Obviously, I know that you guys have done a lot of that in preparation to the MST, but this is a custom question that is not an MST, I think. Like, it's a custom one we made. So try that, and then after 3 minutes or 4 minutes, so I'll discuss it in 11:17, just to give you like a 5-minute break anyway. Okay. I don't know if there's a 5-minute break in this slide, but yeah, just relax for a bit. Yeah, no worries. I mean, it's good to get one. Yeah, I don't believe that's All right, 3 more minutes. I'll discuss in 3 minutes. 11:18. All right. Suppose that string 1 and string 2 are two non-empty pattern strings. Give a single pattern statement that assigns to str3 the string that results when all but the last character of string 1 is placed in front of all but the first character of string 2. Okay. So all but the last character of string 1 is just dot 0 colon the length. Oh, sorry, 0 colon. It could be the length minus 1 or just minus 1. Remember, with slicing, it includes the first index, but it doesn't include the last index. Okay, and then in front of all but the first character is just 1 colon and square brackets. Okay, so you'll get that string 2 string 1 colon negative 1 plus string 2 1 colon. This 0 right here is optional, but you can't put a 0 here. Okay, that's a different meaning, right? This one is, I think, more straightforward. You'd have to make a list comprehension of all the even length, of all the even numbers, and then just put a length over it, or an len. Okay, any questions? Cool, easy. Right, and then you'd have the fill in the blank section. So a fill in the blank is essentially given a function with missing lines, you're asked to replace those lines with code. Okay, so these ones, I'll go to the sample exam later, but these ones essentially is, yeah, you have this blank line with access, and then you have a dictionary. For instance, here there's a dictionary, and then here you can probably see that I'm adding stuff to the dictionary, right? I'm counting the frequency. So clues to look out here, for one, is you can see that the code is usually broken into chunks. So you're gonna give a really well formatted function with a docstring, commenting, good variable names, right? And then you just have like some lines being removed, and then you have to guess what it is. Understand what that specific block is responsible for. So for example, here, this block of quote-unquote 4 lines, you can probably see from here that here I'm initiating the dictionary using dictionary comprehension, and then here I'm adding 1 for every letter I see, which is lowercase. Okay, you can kind of like guess here that this should be a for loop, right? You're gonna loop over each character in W because you're counting the. Sorry, you're gonna loop through. It's gonna be for W. For W, in whatever iterable is here. I'm not sure what iterable there is. For W in words, actually no. For W in words, yeah, for W in words. Sorry. Okay, so this one should be for W in words because you are counting each character in words, as it's already done here actually. Sorry, counting each, in this case it's actually counting each word in words, but variable naming. So here I'm initializing 0 for every word, and then here I'm counting, I'm adding 1 for each word that I see. Okay. The other clue is, well, look out for any specific clues such edge cases. I'm looking for this more, which is pay close attention to the commenting, indentation, and variable names, and the docstring. Okay, so like I said, the function will contain a docstring, it will contain commenting, and it will contain proper indentation like this. Okay, so if you have like an indentation like this, you can expect that the first or like the line before it will be like an if statement, like a while statement, a for loop, or yeah, while loop, for loop, if statement, or something along those lines where the next line has to be indented. Okay, that's a big clue. Anyway, how to approach, yeah, that's that. This is another good example. If you have for x in nums and then 2 subsequently indented block, you can expect that the first blank must be an if, with, or a for loop. With is when you open files, right? If you open a file with the with keyword, you also indent the next line. So that's something to look out for. And then this will be something to do with the if statement or the while loop, or another if statement. Okay. Any questions? I think this one is pretty straightforward. Just takes practice. Yeah, this is another example. If I have this variable and then I have a blank line, and then I have another variable that uses a variable that doesn't exist yet, then you can expect that this line will define what start is. Okay, otherwise it'll be an error. So the function in the fill in the blank section cannot be an error. There will be an answer that doesn't make the function go into a runtime error or anything like that. So you cannot assume that the function will be an error, okay? Like if this is the case, if you don't define start here, this will be a variable error because, or like a name error. So you have to define what start is here as a variable. And then you also have a section where you want to identify the errors. So find any error, trace function call, or explain why there's an error. I don't have an example here because this one is very detailed. I might take a look at a sample exam later. But essentially, simply you're given a function which has like 2 or 3 errors, and then you have like 2 or 3 sample inputs, and then they're gonna ask you to trace the input, what the expected output is, what the initial output is, and then ask you to find the error, classify the error, and then give you, and then you're asked to essentially fix the error or like give the line replacement of code. So it is a really comprehensive question. They're gonna guide you through like each sub question, what you're gonna do in that each sub question. So I don't have an example here because it's a very large question. Okay, but it is important to identify the 3 types of errors. Again, syntax is the easiest to spot. Runtime error is probably harder to spot, right? Especially if you're not having a compiler, you can't really run it. And then logic is the hardest to spot because, yeah, logic. Well, in this case, because you're not having an ID, you don't have a compiler. I guess you could say that runtime and logic is equally hard to spot, but otherwise, logic is harder to spot than runtime. Okay. Trace the function call means run through the code if this was the input. So in this type of question, you'll have trace the function call kind of sub question where you're given an input and then you're just tracing the function call and see what it outputs. Okay, easy. And then the second last section is writing a function. There will be, I'm guessing, three write-up functions. So write a function to do X, Y, Z. Sample input output is given, like in the assignment or like in the MST. You can expect it to be like the MST last section where you're asked to write a simple function and you're given like 3 sample inputs and outputs. This one usually worth the most marks in the exam, okay? So ways to approach, also just practice. Really, there's no secret to it. Understand what exactly is being asked. If it's a wall of text, it usually contains hints. This type of problems can seem complex at first, especially the last question. Try to break down the problem into smaller steps. Try to solve one thing at a time, incremental progress, and give it a go, right? So last sem, I think they made the last question too hard. A lot of students leave it blank. But try and give it a go because even just writing the first defined line gives you marks, okay? So even just by writing like def function x, this already gives you like 1 or 2 marks, which is usually quite decent for an exam that's only worth like 100 marks out of like 100, okay? Getting it correct is far more important than finding the most efficient approach. That's another important thing. Don't use recursion if it's not needed, because if you don't have an ID, so it's really hard to like visualize it. Okay. A lot of students ask what the difficulty of these questions are. Obviously, you can go through the practice exam and see it for yourself. But I would say, so there's 3 questions. There's 3 questions for this function section, at least according to last sem. When we had it last year, it was 4 questions. But the first question is quite simple. I would say it's similar to like project 1, let's say like task 2. And then the second question is like intermediate. So I would say it's similar to like project 1, task 4. And then this one I would say it's probably going to be like project 2's task 2. The really long one, yeah. So it's not hard, But because you're not doing it with an IDE or you don't have a compiler, it's very easy to make syntax errors, runtime errors, and logic errors. Okay, like when you do it in an IDE, like these questions, when you have an IDE, it's very easy, right? But because you're doing it on a Canvas quiz, you don't have access to a compiler. That's what makes it really hard to get full marks for these questions, right? You're writing like 50 lines of code, but you don't have a compiler. You don't know, you can't check if it has a runtime error or anything. Okay? Cool. Any questions?
If we somehow get access to, I don't know, something, will be not as cheap or...
You can't get access to that because you're going to use a lockdown browser. When you use a lockdown browser, the application, it forces exit every other application, and then you can't exit out of the lockdown browser unless it closes the Canvas quiz. Yeah. So you're going to have the Canvas quiz open full screen, and then you can't navigate away from it using the lockdown browser. Yeah. No, you can't. You can't open new tabs. I don't know if you can open new tabs. I forgot, but yeah, essentially you can't go through other tabs. So you can't go through like an online compiler or anything. You can't use a debugger because it's a Canvas quiz. I wouldn't risk it. I wouldn't risk it anyway, even if you can, because you know there's invigilators there, and even though they're not. Yeah, I get that. So that's another good question. I would say if you are comfortable in using 2 spaces instead of 4, that's fine, because we're gonna mark them, like we're gonna human mark them one by one, and like usually we give like, if it's like formatting issues like 2 spaces, 1 space, 3 spaces, like usually we give them benefit of the doubt. Like as long as it's not too ambiguous or it doesn't look like completely wrong, we give them the benefit of the doubt. Like for example, you're like 1 space away from the full marks or like from getting it correct, right? Usually just give it the benefit of the doubt. Yeah. Another thing you could use is you could try using the bullet points. So if you use the bullet points format, you can press you can press tab and then shift tab to tap and untap. Yeah, so you can either use pre-formatted, you can use, okay, don't use paragraph. Just a warning, don't use the paragraph format. I think the lecturer has touched on this hopefully, but you want to use the pre-formatted if possible, because it keeps the indentation, the style of your code the same, okay? But you can also use the bullet points. If you use the bullet points, because you're using bullet points, if you press that, this will go here and it will be like this. You do have these bullet points, but then because we human mark it, it's easier for us to see. Like we can see it, what happens. So I can show you later, but essentially, when you have the Canvas quiz like with that, like there's like a drop down there. Initially, it will be like paragraph by default, but then you can select here and change it into pre-formatted. Okay. Yeah. Any other questions? Important section, so that's good questions. Yeah. How do I prepare for this? Again, practice. Just as any other sections, I would say practice definitely. Don't try and rote learn or try not practice. I think you have to practice definitely. Do the past exam papers. You have 7 on the LMS. You have past exam papers from last year, from 2 years ago. You have past exam papers you have a practice paper that's in Canvas quiz that's released by the lecturers. Practice the ed materials or worksheets if you want to, but I would rather redo the projects 1 and 2 without an IDE, okay? So another thing that I haven't touched on this section, the writing of function, is that the background information or the question will follow a similar format to your projects. So it'll be more obvious when I open up the sample exam, but essentially, you could probably benefit redoing projects 1 and 2 without an IDE, because this writing of function section will be based on your projects. Gives you some familiarity coming into the exam and not having to reread the scenario or understand it. Okay. Cool. Any questions? Good. Yeah, this is the last section, a short answer question. Essentially, there's 3 questions, each decent amount of marks. And then this will mainly test your knowledge in regards to mainly topics from digital ethics, algorithms, recursion, HTML, and text encoding. Okay, so topics that are not coding, topics that are more of theory. It will be tested in short answer questions. I have an example here. Describe 2 key ethical issues a programmer should be concerned about when collecting data. So this question concerns about the digital ethics topic, where you just want to yap about, any of the issues, dual use ethical data use, bias and fairness. Yeah, 1 mark for identifying each issue and 1 mark for a thorough description or explanation or evaluation. Okay, so if you have a question like this, ethical issues a programmer should be concerned about when collecting data, you can just yap about, the data, does the customer know that their data is being collected? How are they collecting data? Does the consumer or like the participants know how their data is going to be used? And etc. Just like yap about those things and you'll be fine. Okay. Cool. How to approach? Unfortunately, for someone like myself, this is the memorization part of the subject. I hate memorization. But this is essentially just memorizing, right? Algorithms, recursion, HTML, especially text encoding, and algorithms as well. This is a lot of memorization, a lot of key terms that you guys probably haven't seen before that you guys need to know what it is in detail. And yeah, it's just memorization, essentially. Theoretically, any slide in the lectures is and can be examinable. So we have had past questions where a lot of students weren't able to find or thought that it wasn't in the lectures, but it's just one particular slide in the lecture, sort of like 50 slides in one lecture that they've missed out on. So it is really nitty-gritty, I'll say. Like one lecture has like 50 slides. So in a week, there's like 150 slides, but any slide in that lecture can be examinable and can be worth like 4 marks, as you can see like here. Okay, so it is a lot of memorization, but do go through everything really thoroughly. Okay, make sure to not miss anything. We are normally looking for keywords or key phrases in your answer. Long answer does not mean you'll get full marks, and likewise, shorter answers doesn't mean you'll get little to no marks. Okay. Cool. Any questions? All good. Just general advice during the exam. Move on if stuck. So please don't be stuck on one really hard one-liner, or don't be stuck on one really confusing like section A, or like, I don't know, like fill in the blanks, right? I know that some fill in the blanks can be very confusing. Please skip onto the other questions first, because writing a function takes as much time as like the other ones. Again, it's probably more important because it has more marks than the initial sections. Give it a go, especially in the function section. Like I touched on earlier, so you are likely to make small errors, or if you write this, you get like 1 or 2 marks. So please just do that. Play by your strengths. Any strategy is better than no strategy. Yeah, interpret that as however as you want, I guess. Okay, any questions? Keep in mind this semester is computer based, so you have to bring your own laptop if you do have one. If you don't have one, you have to borrow it from the university, and you have to submit a request ASAP in their website. Okay, so if you search up university borrow laptop, Unimap borrow laptop, it'll take you to like a form, a Unimap form that you can fill out, and then you can grab your laptop, I think, during the exam itself, like before the exam, inside the REB, or like the exam venue. You won't have an IDE that you're used to because you're doing it essentially in like a Word document. It's a Canvas quiz, so there's no format or anything. Try out the sample exam is very important. We have a Canvas quiz sample exam. If you go to the Canvas, you go to MST's module or exams module, you can find a link to the sample exam that the lecturers have made. It is still closed book. There's no Google. You can't access Google. It'll be a locked on browser, and you'll be you can only see Canvas like full screen. You can't exit out of Canvas until the end of the exam. No Google, no ChatGPT, or no whatsoever. Okay. Don't forget you got this. And yeah, that's it for me. Feel free to ask any questions. I think the CISA people will upload the slides hopefully there. feel free to check out the slides. I think if you scan that QR code, you'll be able to see the slides. And I think we'll distribute it in the social media as well, like the slides, right? Yeah. Okay, thanks, guys. Do you have the, I think I'll just show them. I was planning to like show them like a sample exam, but
Like
yeah.
lockdown Basel?
No, just like the canvas. Like, do you have FSC for like 2023 or 2024?
I don't in particular.
Or maybe.
Let me.
Yeah.
Access to the canvas. 'Cause I'm
I'll stop the.
Okay.
I'll stop the live stream for now.
Yeah,
and
yeah,
Then I'll let
yeah.
them.
Oh no, like the one last year. It doesn't have to be like the one this year.
Yeah. But I'll just end this live stream for now.
Can be like last year, like 2 years ago.
Thank you very much, everyone. We'll be ending the live stream now. Thank you for coming, and look forward to the FOA workshop soon. And just to answer that question, yes, this recording will be posted on specifically the CISA YouTube channel, and that will be there to review. All right, thank you very much, everyone.